So what are the first three things we're going to do? Before we do anything else, what are we going to do? Circle a variable, draw the line of equality, and box the square. So just like in the opener when we did the problem with the square root, we have to get the square root by itself. Here we have to get the square by itself. So I'm going to put a box around the square, which means that we put it around the exponent, but also what's being squared, which is the parentheses. All right, so those three things we need to do before we do anything else. Now, with the box around the square, I can see that there's two things we're going to have to get rid of to get that square by itself. What two things do we need to get rid of? Carl?
Minus 3 and 3.
Yeah, we need to get rid of the minus 3 here and the divided by 3 here. Which one of those should we get rid of first? The minus 3 or the divided by 3? The minus 3? Okay. How are we going to get rid of that minus 3?
Plus 3.
Okay, so we're going to add 3 to both sides. And on the left side, when those 3's cancel, what does that leave? Everything else, right? So it's going to be this whole thing here, this whole square, divided by 3. So we get, in parentheses, 4e minus 17 squared divided by 3. And then on the other side, 0 plus 3 is? 3. Okay, now what? Okay, now we need to get rid of the divided by 3, and we're going to do that by multiplying by 3. So we multiply by 3 on both sides, and on the left side, those 3's cancel, leaving what?
4e minus 17.
Okay, 4e minus 17 squared. Don't forget the parentheses, because that square is outside the parentheses. We need it there to show that the whole thing is being squared. And on the right side, 3 times 3 is 9. Okay, now what?
You square 4e minus 17, and it cancels out the square.
Okay, good. So now we have to take the square root to get rid of the square. So we're going to take the square root on both sides. Now this is the step where it's a little bit different than any other equation we solve. Alright, it's going to start just like normal. So the square and the square root cancel each other out, and that leaves what? 4e minus 17. And on the right side we get 3. But then we also have to keep in mind, we get 3 here because 3 squared is 9, right? 3 times 3 is 9. What else can I square to get 9? What else do I multiply by itself to get 9? Besides positive 3? Negative 3. So at this step, when we take the square root of both sides, we're going to get two equations. We're going to get this one, but then we're also going to have another one that says 4e minus 17 equals negative 3. So we're going to write two different equations at this point. One that has the positive square root, which is the positive 3. One that has the negative square root, which is the negative 3. What do we do next?
Plus 17.
Yeah, so let's finish this equation up, and then we'll go over to this one. So we just have two equations to solve like we normally do. So we're going to add 17 here. We do that on both sides. And on the left side, when those 17's cancel, what does that leave?
4e equals
20? Okay. Then what?
divide by 4e.
Divide by 4, just 4, right? So we're going to divide by 4 on both sides. And when we do that, we get...
E equals 5.
Alright, so that's one of our answers. E equals 5. But it's not our only answer. We're going to get another answer from this over here. So since I need to solve this equation, I'm going to start... I don't need to circle the variable, but I am going to draw the line of equality just to help me keep my work organized there. And what do I need to do to get e by itself there? Add 17. So it's really the same step, except the only difference is, yeah, on the right side we're adding to a negative 3 instead of to a positive 3. So we get 4e equals 14. Okay, then we need to get the e by itself still, so we do what? Divide by 4 on both sides. On the left side, those 4's cancel, leaving e all by itself. On the right side, what's 14 divided by 4? Get a big long decimal, right? So if you punch that into your calculator, you get a decimal. We don't like decimals. At least we don't like decimals that are big, long, keep going. Calculator only shows so much, but it's going to just keep going and going and going forever. All right, so instead of doing that, we're going to write our answer as a, what is this right here? 14 over 4. It's a fraction. Now, 14 over 4 would be a good answer, except, what's the problem with this fraction? Well, it's an improper fraction. That's okay. There's no problem with that. But what is the problem with this particular fraction? What can we do with it? We can simplify it. What goes into 14 that also goes into 4? 2. So we're going to reduce by 2. And when we do that, what do we get on top? 7. And what do we get on the bottom? 2. So our second answer to this one is going to be a fraction. It's going to be 7 over 2. So we get e equals 5 as one possible answer. And we get e equals 7 halves, or 7 over 2, as a second possible answer. And again, like the other ones, we have to get both answers because they both work. Example number 5. This one looks a little different. Why does this one look different? Yeah, well, it's got a bunch of squares, right? So the ones that we've seen so far have only had one square. So when I'm setting up this problem, I'm going to circle the F. I'm going to draw my line of equality. Does that mean that I want to put boxes around all the squares? Do I want to put a box around this square, and this square, and this square? No? Why not? The directions say to put a box around the square, so why don't I put it around all of them? Which one do I want it around? Carl?
The F squared.
The F squared? Why?
This is a variable.
Okay, good. So the only one that we really need the box around is this one, because it's the only one that has the variable. The other stuff, the other squares, we can just simplify those. We don't have to get rid of those squares by taking a square root, but we can get rid of those squares just by figuring out what 6 squared is and what 4 squared is. Alright, so that's actually the first thing we're going to do. We haven't had to do this in any equations yet, but what we're going to do is we're going to simplify this equation first before we do anything else, before we start getting rid of stuff. Alright, so to simplify it, I'm going to simplify this 6 squared, which is what? What is 6 squared? 36, right? Because it's 6 times 6. So I'm going to rewrite it. Instead of 6 squared, I'm going to write 36 here. And the other thing I can simplify is the 4 squared, which would be 16. Alright, so I don't know what f squared is because I'm trying to solve for f, but I can replace the 4 squared with 16 and I can replace the 6 squared with 36, so we get something that looks like this. What do I need to do next? I put a box around this f squared here to remind myself I need to get that by itself. So to get the f squared by itself, what do I need to get rid of? I can't get rid of the square yet because I have this 16 over here. So I have to get rid of that plus 16 by subtracting 16. So I'm going to subtract 16 from both sides first. And when I do that, the 16's over here cancel, leaving just f squared. And on the left side, what's 36 minus 16? 20. All right, now what? Yeah, now we got to get rid of the square by taking the square root. So we'll do that on both sides. On the right side, the square and the square root cancel, leaving what? F. On the right side, is 20 a perfect square? No. So what do you think we're going to have to do there? Simplify it. How do we simplify a square root? You guys remember how to simplify a square root? We have the square root of 20. What do we do first? Factor tree. Rewrite it. Circle pairs. What do we do with the pairs? Put the pair on the outside, keep the 5 on the inside. And so the square root of 20 is the same thing as 2 square root of 5. So that is going to be our answer there. Now, is that our only answer?
No.
No. What is the other way that we could take the square root of 20? The other thing we could take that we could square to get 20?
Negative 2 square root of 5.
Exactly. Negative 2 square root of 5. So we could get the positive square root, which is 2 square root of 5, or we could get the negative square root, which is negative 2 square root of 5. Oops. Now, is there anything else I have to do to get f by itself for either one of these? Nope. So that's it. So you get negative 2 square root of 5 as one possible answer. You get positive 2 square root of 5 for the other one. I don't know if I said that right. We get the negative and the positive as possible answers there. When possible, you need to simplify your square root answer. So we can't just leave it as a square root of 20. We don't want to plug it into our calculator and get 4 point something and get a big long decimal. But we do need to simplify it however we can. All right, so this last one is going to be kind of similar to that. I want you to try this one on your own. See if you can get this. So just like the last one, we only need to box one of the squares, the one with the variable in it. So we're going to box this one. That square we need to get by itself before we can get rid of the square. But it's already by itself, right? So should I start off right off the bat and take the square root of both sides? What would be the trouble with that if I try to take the square root of both sides right now? The trouble with trying to take the square root right now is that this is not something right here that we can take the square root of. Okay, it kind of looks like we might be able to because it has squares, and when you take the square root of a square, you get rid of the square. But the problem is this plus in between, and that would cause some trouble. But what we can do is we can rewrite it. Instead of 5 squared, we can write 25 plus 25. And on the left side, we still have g squared. Now, once I do that, I still can't take the square root of the right side yet because it's 2 terms. So what could I do to make it one term? Emily? We don't want to do that. Yeah, we can just add them together, right? How about we just do 25 plus 25? What do we get? 50, right? So we can just combine these because they're like terms, and what we get then is g squared equals 50. Now that we have one term on the right side, now we can take the square root of that. So we can take the square root to get rid of the square here on the g, and if we take the square root on the left side, we have to do it on the right side. Alright, so on the left side, when the square and the square root cancel, we get g all by itself. On the right side, is 50 a perfect square? No, it's close to 49, which is perfect square, but that doesn't really help us. So what are we going to have to do with that? We're going to have to do a factor tree and simplify, right? So you guys get 5 square root of 2? Okay. So the square root of 50 is the same thing as 5 square root of 2, so we get g equals 5 square root of 2, and we're done, right? No. What else do we get? What other possible answer could we have here?
Negative 5. The square root of 2.
Yes. So we get, whenever we take a square root, we get the positive answer, but we could also get the negative answer. So g equals 5 square root of 2, or g equals negative 5 square root of 2. And those are both possible answers for g. If we put either one of those in here for g in the original equation, this equation is going to work.